Hey, what is going on? It is Wednesday, April 6th, 2022, and I am ready to go with another Leetcode problem. It is the middle of the week, hump day, and this is fun and exciting for me because I always like to warm up my brain with a coding exercise that seems trivial, but is maybe not so trivial, but does give you a good, or the working on it helps you get a good grasp of some computer science fundamentals and some clever ways to work with work with data structures. Okay, so that's my preamble. So if you like this video, like, subscribe, comment on the link below, and please let me know how I'm doing, and I appreciate all the feedback. So again, this problem here is called, this is 1370, increasing, decreasing string. Labeled as an easy. I'm gonna like this problem here. It has more dislikes than likes, and maybe we can figure out why from when we read it. But you are given a string S, reorder the string using the following algorithm. Pick the smallest character from S and append it to the result. Pick the smallest character from S, which is greater than the last appended character, to the result and append it. Repeat step 2 until you cannot pick any more characters. Okay, so the first steps 1 and 2 get repeated until you can't pick any more characters from the string. Pick a 4. Pick the largest character from S and append it to the result. 5. Pick the largest character from S, which is smaller than the last appended character, to the result and append it. 6. Repeat step 5 until you cannot pick more characters. So this looks like another loop here, where we're picking the largest character, and we're picking the largest character that's greater than the last character added. Repeat steps 1 to 6 until you pick all the characters from S. In each step, if the smallest or largest character appears more than once, you can choose any occurrence and append it to the result. Return the result after sorting S with this algorithm. Okay, so at the end of the day, let's look at the example. We have S equals A, B, C. And the output is A, B, C, B, A, B, C, C, B, A, B, C, C, B, A. Okay, so basically, let's go through it. We have A, B, C, C. So there's 4 A's, 4 B's, 4 C's. And so what are we going to get to? We're getting to A, B, C, okay? C, B, A, B, C, C, B, A, B, C, C, B, A, B, C, C, B, A. So the thing to note first is that we use all the characters, right? So we have 4 A's, so we end up in the final string having 1, 2, 3, 4 A's, okay? 4 B's, we have the final string 4 B's, and the 4 C's in the final string we have 4 C's, okay? C. Okay, so this is the kind of tricky part about this problem, right? Like, first of all, like, because you see the smallest and largest in there, you should think that sorting is involved in this somehow, okay? But at the same, so we can conceivably sort something here, right? But also, as long as this is sorted, we also have to keep the total count of characters available to us known, right? Like, we have to understand, we have to keep track of that, because if this was, for example, A, B, C, A, right? Then essentially we wouldn't be able to paste this last A, because we have only 3 A's that we've kept account for. Or what if it was 1 less B, right? We wouldn't be able to paste this B over here. This B over here. So again, we have to keep track of both the order of the keys, and we have to keep track of the total count. So I'm thinking what we do is we use a hash map or a frequency counter to keep track of the count, and we also have to order the list of available characters, right? So there's efficient ways to do this, probably different interesting ways to do this. I like to, like, a problem like this, I like to try to do something a little different. So what I'm gonna do is, first let's construct the result. Result equals new string builder. Okay, so this is what we return, right, as we build a string. And I'm going to do this here. So my algorithm that I have in mind is that I'm going to alternate, as they said, in 2 loops. And I'm going to append pieces of the strings together. You'll see what I am talking about in a second. So in this case, we have sorting and we have frequency count to simultaneously keep track of. So what can do that? Well, there is a data structure called a TreeMap. And this is you can look it up when you have a chance, but this is a data structure which is a map which has some inbuilt sorting. The backing data structure of a tree map is called a red-black tree, and it's pretty fundamental and important to know in computer science. But this tree map lets you sort keys based on their value, and also count their frequency. So if I add, you'll see what I'm talking about. So I'm going to add the characters to the tree map. 0. That's the length. Okay. So map.put default. Okay. So what I'm doing here, I'm adding each value to the tree map, and this tree map automatically gets sorted. So I'll show you what the implication of this addition, the way it is in a second, is specifically. But essentially, as the keys get added in, so it doesn't matter where the keys are. If I have some random string with like, let's take this here, right? Okay. So basically, let's call it this, right? So what's going to happen is the final key association in the tree map, if we iterate through it, is going to be A to 4, or A to 3, C to 2, T R to 1, T to 2. Okay. And so this is important because that means that, because a normal hash map won't preserve this iteration order necessarily, okay? Normal hash map does not preserve the lexicographical order of the keys, okay? So if I iterate through a normal hash map, I'm not guaranteed to always get A, C, R, T in that order, okay? But in the tree map, I am key ordered. Okay, this is important for the way the algorithm I'm writing is going to work. So, while k is less than s.length, I'll show you what I'm talking about in a second. So this is what I'm calling my outer loop. K into k equals 0. This is my build index. Okay, this is the index I'm going to keep track of to build my final string. Okay, so let's do this. Set character keys equals map.keySet. Okay, so this is my set of keys, and again, remember, this set is now always going to be ordered lexicographically. Okay, that's very important. Okay, now I have my outer loop. Now how do I do my inner loop? So remember what I said, I'm going to construct this final result, right? I'm going to go like this. Bam, 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 bam. I'm going basically forward order and then reverse order. So because if you look at it, again, let's look at the string, right? This turns into, let's go back to the original string. It's very easy to see when you look, right? So A, B, C, and then C, B, A. Okay, look at these fragments. Right, fragment, reverse fragment, fragment, reverse fragment. And again, the only reason this looks so symmetric is because there's an equal number of all the keys. But if I miss one key, if I'm losing a key, then I'll have to subtract a key out of here. But again, you're still going in reverse order. Okay, then this fragment only becomes 2 here. Okay, so that's why I'm gonna create, now that I have my piece, I'm going to do piece dot set length 0. So that's clearing whatever was in there already. Nothing is in there from the very first iteration, but there will be. So here is the magic sauce. Character key dot keys. If map get key is greater than 0, piece dot append key. Okay, now what I'm doing, and then the final thing, this is the most important part actually of this, or the trickiest part maybe. Or default -1. Okay. So basically what am I doing here? This is my first inner loop. I'm constructing the keys from the set in available order, and I'm checking whether the value of the map for the particular key is greater than 0. Again, this is important because we're taking available characters out of our frequency count map, okay, and we're appending them to this piece. So A, B, C, right? Once we run out of B's, for example, this piece will turn into A, or C's, this will turn into A, B, and then into A once we run out of B's. Okay, so this is what this is doing, making sure that the total count is respected. Then append piece, okay, and then I do piece dot set length, because now that I've iterated in the forward order, I have to iterate in the reverse order, because now I'm constructing the reverse fragment. Keys. Okay. If map.get key greater than 0, again the same logic here to keep track of the count. Keys.insert 0 key. Okay, and now here map.put key map get or default key 0. There's 1. Okay. All right, and then result dot append piece. Okay, we're appending this total to the total string builder, and then we are returning the total result to string. Okay, so again, in this iteration here, I'm doing the reverse thing, and you can see how I'm indicating this is the reverse operation, because the piece that I'm now constructing will insert into the 0th element, so it'll be C, B, A. I'm still iterating A, B, C, but because I do this here, it inserts that piece in reverse, because it always puts it in the 0th position of the string. Okay, so, and then we append these two together. Again, this piece is appended here, and then we finally have ABC, CBA, ABC, CBA. Let's see if this makes sense. I have to get rid of these test values. Map.key, map.get or default 0. And we need to return. One other thing you gotta do. I forgot. Remember, we need to keep track of this build index. okay? Because this is the total length. Our iteration is keys less than the total length. So, okay, accepted. All right. So remember, just let's try this whole thing, see if it works. And there you go. Slow as heck. Space is not too bad. There could be faster ways of doing this for sure. I can optimize this by probably not even using a tree map, just using 2 other data structures to keep track of this sorted array. But I just wanted to kind of try to use this like unique data structure to do this. And yeah, if you like this video, like, subscribe. It's a long one, but like, subscribe, and click on the link below and all that good stuff. Thanks for watching. I'll see you around.